So in this video, we're going to look at how we can approximate the value of a function with a Taylor polynomial. So I'm going to come back to Taylor's theorem, but essentially what we're going to do is we're going to approximate the function with the formula from Taylor's polynomial. And so we'll evaluate f of c, then plus f prime of c will be the first derivative evaluated at c times x minus c, and so forth until we get to whatever degree polynomial we want to evaluate. And so I'll go over an example and I'll come back and talk about the remainder. So let's say I want to evaluate f of x equal to sine x, and let's say I want to evaluate the fourth degree polynomial, and let's say we want to evaluate the Maclaurin polynomial. So the Maclaurin polynomial is just where c is equal to 0. And so I'm going to start off, I like to make a table of values. So this will be my f. F is sine x. And then we'll find our c. C equals 0 in this case. So this will give me sine of 0, which equals 0. And then f prime will be cosine of x. And then cosine of 0 is equal to, sine of 0 is 0, cosine of 0 is equal to 1. And then f double prime will be negative sine, and negative sine of 0 is equal to 0. And then f triple prime will be a negative cosine of x. So negative cosine of 0 will be equal to negative 1. And then the fourth derivative, f to the fourth, will be equal to, back to sine again, sine of x. So sine of 0 is equal to 0. So notice it's a fourth degree polynomial, but we'll have 5 terms. The 0 term, that's just f of whatever value we're evaluating, whatever c is. And then the first, second, third, and fourth. So that's a total of 5 terms. And so we'll typically write this as p to the fourth x will be equal to our first term will be 0, and then plus 1 times x minus 0, and then plus 0 times x minus 0 squared over 2 factorial, plus negative 1 times x minus 0 cubed over 3 factorial, and then plus 0 x minus 0 to the fourth over 4 factorial. So I wrote the 0 terms in here. Of course, you don't have to. And then p to the fourth x will be equal to just x minus x cubed over 3 factorial. Okay, the remainder, let's go back to what Taylor's theorem tells us. So for any degree, we just list each term. The coefficients of each term are the derivative evaluated at c. And so the value of the function will be all of the terms up to the nth term, and then plus the remainder, where the remainder is equal to the next term, f to the n plus 1, evaluated at some numbers z, which is essentially the maximum value that the derivative takes between x and c. And then we also know that the remainder will be less than that term. So the remainder will be less than this term. That's essentially your error in using the polynomial to approximate the value of whatever function you're evaluating.